Day by day, week by week, you go about your everyday lives and never once stop to think about the science behind it all. Whether it's as simple a task as picking up a pencil or kicking a football, you are demonstrating some of the most famous scientific theories of our time. Without one man's crucial scientific discovery, we would have very little knowledge in the fields of gravity and force as we do today. And that man was Sir Isaac Newton. Newton was walking in his garden one day when he noticed an apple fall off a nearby tree. And then, suddenly, an idea struck him. Several ideas. Newton spent many years exploring physics and creating new laws, which we will be experimenting with today. This is Andy, and this is Ben. They will be our test subjects for today. Newton's first law of physics states that any object in motion will stay in motion unless acted upon by an outside force. Here, we will be demonstrating that by throwing a ball. Freeze it! Okay, as we can see here, the ball is in motion due to the force from Andy's throw. If the world had no air and no gravity, the ball would just glide like that forever. Unfortunately, that isn't the case. On Earth, we have two outside forces acting on the moving object: air resistance and gravity. If Ben weren't in the way, the ball would have eventually fallen to the ground. Newton's second law said that the net force is equal to the overall mass of an object multiplied by its acceleration, that the acceleration of the object is equal to the net force acting on it divided by the object's mass. Here, we shall demonstrate this with a simple kick of a ball. Freeze frame. Okay, so here, let's say the force from Ben's kick is equal to 400 newtons, while the object's mass is, say, 200 grams. If we apply Newton's second law of physics, we can conclude that the acceleration of the ball is 2 meters per second squared. And finally, we come to Newton's third law. This law states that for every action, there is an equal and opposite reaction. By that, whenever an object exerts a force on another object, the second object exerts an equal and opposite force back on the original object. This law can be demonstrated by a simple game of pool table. Freeze it! Now, as you can see, when the cue ball hit the black ball, not only did it cause the black ball to move, but it also caused the cue ball to stop in its place, hence equal and opposite reaction. And thus, those are Sir Isaac Newton's 3 laws of physics. Thank you for watching, I hope you learned something, and remember, gravity isn't just a good idea, it's the law!